Hey everyone, welcome to another ALEKS tutorial video. In this one we're going to be writing the Lewis structures for a molecule with resonance. So there's a few different simple steps to follow for this one. First step is determine the total amount of valence electrons in the substance you're dealing with, and then we want to write the central atom, which is the atom in the middle connected to all the terminal atoms. Then we draw a single bond to the terminal atoms, add valence electrons, and add any additional bonds in order to satisfy the octet rule. And then don't forget to add the charge at the end, which is going to be whatever charge is shown here. In this case, this nitrate has a total charge of -1. So we're going to want to note that the total charge is -1. So if we want to find out how many valence electrons in this polyatomic ion, then we only need to look at the group that each of our atoms is in. So we have nitrogen first off, and this is in group 5. So nitrogen is going to have 5 valence electrons. And then we have oxygen. And we have 3 oxygen. Oxygen is in group 6, so we know that oxygen has 6 valence electrons. And we have 3 of them, so we're going to multiply this by 3. And we only have 1 of the nitrogen, so we just multiply that by 1. So 6 multiplied by 3 gives us 18. 5 multiplied by 1 gives us 5. And then we also want to take into account this -1 charge. The -1 charge indicates that there's an additional electron, because an electron is negative. So we have an additional 1 to add to this, and so we just add these up. So 18 plus 5 plus 1 gives us a total of 24 valence electrons. So that was step 1. The next step is write the central atom. So we'll go down here, and just as a reminder, we are writing the Lewis structure for nitrate. That should go inside the parentheses, technically. Okay, so step 2 is write the central atom. Well, we have 3 oxygens, and we only have 1 nitrogen, so we know that nitrogen is going to be the atom that everything else is connected to. So we'll write N as our central atom, and then the next step is to draw a single bond to every terminal atom. Well, we have 3 oxygens as our terminal atom, so all we need to do is just draw a single bond to our terminal atoms. And then we will add valence electrons to our terminal atoms. So we already have 2 electrons in this single bond that we've created, so we just need 6 valence electrons to add on to these. And now we're on to step 5, which is draw any additional bonds to satisfy octet rule, and also satisfy the number of valence electrons we need, which is 24. So first, let's see how many valence electrons we have already. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we actually already have 24 valence electrons. But that's a problem, because we may have satisfied the amount of valence electrons, but our central atom doesn't satisfy the octet rule. So what we can do to fix this is we can make one of our single bonds into a double bond here and erase one of our lone pairs. So if we do that, we now have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 valence electrons, as we should, and we also satisfy the octet rule for our nitrogen, 2, 4, 6, 8. And so, step 6 is, don't forget your charge. So nitrate has a charge of -1, so you want to add your bracket in here and add your -1 to the top of it. And so this, you might think, would be our total answer. But wait a minute. Why did I decide to add a double bond to this oxygen when I could have added it to this one or to this one, and I would have satisfied the octet rule? Well, that's the purpose of resonance. Just because this is one of our answers doesn't mean it's the only answer. We could have chosen to write a double bond for either one of those other oxygen atoms. So, what we have to add to our answer here are the resonance structures. So we write our resonance arrow, and I'm doing this on a tablet, so I can copy and paste. All we need to do is just rewrite each different variation of the resonance structure that we have. So we could have chosen the top oxygen atom to have our double bond. We could have chosen the left one for our double bond. And so we need another one, another resonance structure, to represent that we could have chosen the rightmost oxygen atom as our double bond. And so we do another resonance arrow, and then we'll erase the double bond for this one and refill the valence electrons, and add a double bond for the right one, and erase one of our lone pairs, and there you have it. So this is your answer. It's not just one of them. One of them is incorrect. You have to represent that it could be any one of these three, and this is what we call a resonance structure. Alright, so this would be your answer to this problem. I hope this helped, and thanks for watching.